So what is Arduino? Arduino is a open source. No, that's not how we do here, right? So basically what Arduino is in layman's term, if you try to perform some operation based on some conditional flaws, or like the conditional you try to implement on the Arduino, you can do it. Like if I press the button, turn on the lights. It's easy, right? Arduino is easy. Like it's really easy. Like it takes 2 minutes to get started with Arduino. It has many built-in functions for IOs, ADCs, delays, mapping, and interrupts. It has good support for libraries and a lot of developers codes in Arduino, from beginners in standard 3 to like professionals into this industry. But why exactly are we trying to eliminate the ready-made Arduino boards that you can buy from the market from our projects, right? First of all, it's meant to be clear we're not trying to completely eliminate Arduino kids. We are just using the off-board solution for making our projects more practical and more customizable. First of all, they are expensive. If you go to the Amazon right now, you can see the actual prices of microcontrollers and the Arduino kits. Trust me, the difference is phenomenal. And making off-board solutions make the project entirely versatile. We can always eliminate the unused ports, the programmer, the debugger. Like we don't need it in our software. Why would you keep it? So that's why in this video, we're gonna make it happen. Let's go. However, we recommend having Arduino kits in hand for testing, debugging, and programming purposes. They're very easy to set up and use. At first, we shall type arduino.cc on the browser. Go to the software, then downloads. Scroll down, you can see a lot of options for different operating systems. Since we're using Windows 10, we'll choose the first one and download. Now let's start with preparing the programmer Arduino board to program our target chip. We shall connect the USB cable from PC to an Arduino Uno. We'll use an Arduino Uno as ISP, aka in-system programmer, which will use SPI or serial programming interface to load programs into the target microcontroller. Then we shall open Arduino IDE, find the Arduino ISP sketch in the examples and load it. We will note down the I/O pins used and hit upload. Now that we have our Arduino ISP board ready, we will proceed to prepare a blank microcontroller chip to program it using the Arduino IDE. First of all, we'll need to burn the bootloader of the blank chip. We are using SPI mode to burn the chip. We will look into the datasheet and identify the master out slave in, master in slave out, serial clock, reset, VCC and ground pins. The SPI is usually connected to a 2x3 header pin like this. Feel free to look at the schematic diagram clearly given in the description below. Now let's move on to preparing the target microcontroller on a breadboard with a 16 MHz crystal and a 10K pull-up resistor to the reset pin and a couple of other components. It's a good idea to check the continuity of the jumper wires before using them to avoid really unpleasant surprises later. After checking all the jumper wires, we shall start connecting the target to the Arduino that we prepared as the programmer earlier. Finally, we will plug in the USB cable from the PC to the programmer Arduino board. We shall open Arduino IDE. In the navbar, we shall go to the tools. Going to the tools, select the board as Arduino Uno. Select the port where the programmer Arduino is plugged in. Select the programmer type to Arduino as ISP. Finally, we click on Burn the bootloader. Now that we have prepared the target microcontroller, we can program it using SPI and UART. But at first, we will upload the program using SPI. We can use the same Arduino as ISP board as programmer, connect the MOSI, MISO, SCK, reset, VCC and ground pins to the target to program it. Or we can use some special programmers like USB ASP, which is very inexpensive and widely available, and it's open source. The connections are almost the same for both Arduino as ISP and USB ASP. However, a schematic explaining the connections can be found in the description below, as always. Now, we'll connect a test LED to pin 16 or digital pin 10 of the target chip and plug the USB ASP to the PC. We will write a program to fade the test LED and upload it using SPI protocol to show that it works exactly in the same way as a normal Arduino kit would do after the uploading. And as always, link to the codes can be found in the description below. Now that our example program is ready, we will proceed to upload it to the target chip. We will go to the tools and select the program as USB ASP and go to Sketch and click on Upload using Programmer. As you can see, the program works. Now, there is also another programming mode known as UART, aka Universal Asynchronous Receiver Transmitter. This only uses two wires to transfer and receive the data serially without requiring any clock pulse like SPI. We can also furnish with the programmer a handshake signal to the reset pin of the target to automate the programming process. Otherwise, we would have to reset the target IC manually just before you begin the program. We will connect the 5V pin to the common power rail of the circuit and the ground to the common ground. As we had already shown you the Arduino on a breadboard, to keep it interesting, we'll now build it on a perf board. Here, we will use a USB to TTL converter as our UART programmer, PL2303. We will connect the TX pin to the RX pin of the target IC and the RX pin to its TX pin. For this, we will need the following things: Atmel 328P with a burnt bootloader, a 28-pin IC base for the Atmega chip, a 6x1 and a 14x1 male headers, a 5x1 female header, two 22 picofarad disc capacitors, a 16 MHz crystal oscillator, 3 LEDs, 3 10 kilo ohm resistors, a 6x9 perf board, and a USB to TTL converter PL2303. Now let's start assembling the components as needed. Next comes soldering the essential components. Now that we have got our board ready at hand, we'll try using different methods to upload the code. We can upload the code using Atmega 32U4 programmer present in the original Arduino board. For the first one, we need to connect the TX pin of the target IC to the RX pin of the Arduino board and the RX pin of the target IC to the TX pin of the Arduino. Next, we connect the common power rails, the common grounds, and the plus 3.3V to the plus 3.3V on the Arduino board. We achieve this using the jumper wires. We will need to eject the target IC on the Arduino board in order to make it clear that we are trying to target a separate IC apart from the one in the Arduino board. As you can see, the program works. We can also achieve the same by grounding the reset pin of the Arduino board. As you can see, the program works. Or we can use our USB to TTL converter which we specified earlier. And for the second one, we got our female header in place. We're just gonna connect the USB to TTL connector to the female headers. But hold on, before we start programming, we might want to install the driver for PL2303. Like always, head on to the description for the download link of the driver and install it. After you're done, plug in the PL2303 converter and check if Windows recognizes it. In case you're out of luck, it will say PL2303HXA phased out since 2012. Follow the procedure in the video to solve this issue. Open Device Manager, click on the ports, double-click on the device, go to the Driver tab, click Driver Update. Instead of Auto Search, browse your computer for the older version, that is 2008. Then click on Next. It should be working by now. We will now try running our basic Arduino Blink sketch. Seems to be working fine. Let's upload a few basic examples. Let's write the first one from scratch. We will be programming this IC in such a way that it maps the value from an ultrasonic sensor into a real-time PWM signal to a small LED. First, we're going to include the ultrasonic library. Then we're going to declare an ultrasonic class with an object declaring pin 13 and 12 as our echo and trigger. We're going to declare a variable called distance. In this setup, we'll declare the pin 19 to be the output. Then we're going to listen to the serial at 9600 baud rate. Then we're going to call the read function to get our distance in centimeters. We will print the distance value in the serial monitor. Then we're going to declare a variable called value and map the distance to the brightness of the LED we want to light up. As you can see, it works fine. We can also do other similar projects apart from the simpler ones. Next, we'll be uploading another basic example, fade. But instead, we will increase the frequency of the fade up, fade down by decreasing the time delay at the end of the infinite loop. As you can see, the program works. For here's one, the Pong game. As you can see, it works fine as well. Okay, you got the idea. Now go on and play with your Arduino kits and microcontrollers. Great, stay tuned for more. See you later.